Hello, I welcome you all. The problem reads, locate the centroid x bar over a quarter elliptical area as well as y bar. So we are being asked to locate both the x bar and the y bar over the quarter elliptical area. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right. So what is a centroid? What is a centroid? A centroid is just basically the geometric center. All right. So we have what is called the geometric center of a line. We have what is called the geometric center of an area, like in this particular case. We have also what is called the geometric center of a volume, right? So we have what is called centroid of a line, right? We have what is called centroid of an area, centroid of an area. We have what is called centroid of a volume, right? And when the material is homogeneous, this means the material properties at every point throughout the body of that particular material is the same. Same material properties at every point throughout the body of that particular material is the same, right? E.g., density, elastic Young's modulus, Poisson's ratio, and so on. So when the material is homogeneous, then the centroid coincides, and if the body is acting within a uniform gravitational field, then we are saying the centroid coincides with the center of gravity as well as center of mass. Great. So this is about it. Let's dive into solving the problem. So we are going to get a small strip so that we define everything on a small strip, and then later on expand that strip, okay, over the function that is given by integrating, right? So let's get a small strip along the x direction. We get a small strip, very small strip, and this strip, we think of it as a small rectangle, okay. It has a very small thickness we are calling dx, okay. And its height is y, right? It's being controlled by the function y, all right. So this function of the ellipse, we can write it in terms of y, and that's the height of this small strip. And then this small strip, it will have its own small centroid, okay. This centroid, we are calling it y curled is equal to y, okay. All right. And then it will also have its own centroid or axis, I mean location. In the x-axis is x curled is equal to x, right? And its small area dA is equal to y dx, right? Okay, so let's write the equation of y. Let's write the equation of y. So we have y squared divided by b squared, right, is equal to 1 minus x squared divided by a squared. Then if we made y subject to the formula, this becomes equal to square root Okay, supposed to be positive or negative, but of course we are just focusing on the positive part. This becomes a b squared minus b squared divided by a squared by x squared. Factoring out the b squared, the b, y becomes equal to b outside, then square root of just 1 minus x squared divided by a squared. Right. Then our x bar is going to be equal to integral of x squared dA divided by integral of total area itself, which is going to be equal to 0 to a. Since we are integrating along the x-axis, our dA is a y dx, so this becomes x squared is just x, like so, and then dA we say is just y dx, and then divided by integral from 0 to a y dx. So we are replacing this this y there, we need to replace that. We also need to replace this y there. Okay, so if we did so, we are going to have the following expression. Our x bar is going to be equal to integral from 0 to a x, we factor out the b there for the y, and then we have square root of 1 minus x squared divided by a squared dx, right? Yeah, and then divided by integral, we also factor out the b. Okay, this b, this is from 0 to a, then square root of 1 minus x squared divided by a squared dx. Great. So b and b will cancel, but let's not forget that the total area has a b. That we must not forget. Okay, so let's start integrating this one by one. Let's start with the top. Integral of from 0 to a of x 1 minus x squared 1 minus x squared divided by a squared dx. So this, you would work on this one by letting let u be equal to 1 minus, this is integration by substitution, 1 minus x squared divided by a squared, and you know that your du dx is going to be equal to minus 2x divided by a squared. So using the 2, you replace this and then do the integration, which I'll not show in my work. In fact, okay, I won't show. This is something that you can do on your own. Okay, this is something that you can do on your own. So if you did this on your own, you are going to find that your expression for this integral from 0 to a x gives you x is equal to, this will give you it will give you this expression, minus a squared divided by 2 divided by 2, right? And then we have open brackets 2 over 3, we have 1 minus x squared divided by a squared to the power 3 over 2, close bracket, and evaluating it from 0 to a. And if you did the evaluation, you find that you get a value of this is equal to a squared divided by 3. Okay, here we get a squared divided by 3. Okay, so we found one part. You can integrate it yourself. So integration from 0 to a of x, x times root of x over a squared dx gives us a squared divided by 3. Okay, so let's go to the bottom part, which is the total area, but we've cancelled out the b. So this one is integral from 0 to a square root of 1 minus just x squared over a squared dx. Okay, so how can we integrate this one? This one also you can integrate by a substitution. So you'd say let x over a be equal to, this is one of the ways, sine theta, right? And then writing this x becomes equal to a sine theta, and therefore your dx d theta becomes equal to a cos theta, right? And if you wrote this, did everything else, you find that you are going to arrive at this expression. Where you will have the following expression, which is integral from 0 to a of 1 minus x squared divided by a squared dx is going to be equal to, this is going to be equal to, open brackets, you will have a divided by 2 arc sine x over a, okay, plus 2x divided by a squared square root of a squared minus x squared close. Okay, so all this bracket here, let me enlarge this bracket here, goes with this one like that. Okay, and then we have the bigger bracket, then we are evaluating from 0 to a, and therefore this gives us, if we do everything else, we are going to have the following expression. This is going to be equal to a pi divided by 4. Okay, and therefore our x bar is going to be equal to integral from 0 to a of x root of 1 minus x squared divided by a squared dx is equal to a squared divided by 3, then everything divided by integral from 0 to a square root of 1 minus x squared divided by a squared dx. We have a pi divided by 4. Then x bar is equal to 4a divided by 3 pi. Okay, so found what x bar is. We found what x bar is. Mind you, don't forget that the value of the total area from 0 to a dA is equal to, like I say, you don't forget the b that we cancelled out, is b times a 4 over a pi over 4, which is equal to ab pi over 4. This is the total area. This we don't need to forget. okay, because we'll come and use it later on when we calculate y bar. Great. So let's go to the next page. Let's go to the next page. We find y bar. We find y bar. Of course, everything else remains the same. This is our dx, right? This is the height, which changes, being governed by the function y. And we said our dA is equal to y dx, and the function itself of y is b, okay, like so. Then 1 minus x squared divided by a squared, right? Great. So therefore our y bar is equal to integral of y cubed. Mind you, we found y cubed is from there to there, and this we said y cubed is equal to y over 2, right? This is what we said, the y over 2. Sorry, this is y over 2 here. Okay, this is y over 2. Okay, this is y over 2. And then the x there, this one is just the one which is just x. Okay, great. So y like that, and then we have the a. Again, these are just the moments of area, right? An integral of just the a. Mind you, this we already know this. We already know this. We are saying is ab pi over 4, right? Let's check that. ab pi over 4. Great. So we know that already. So then let's move on, so that we start now. Just we deal with the top part. So integral, again, from 0a to a, we are going to use the same dA. Then y cubed is just y over 2, then times our dA, which is y dx, and this is equal to, we are just solving the top part because the bottom we already know it. This becomes, we factor out the half, then this becomes y squared dx, and then we know that our y is nothing but b square root of 1 minus x squared divided by a squared, right? Squared like that, right? Dx. Okay, so this becomes equal to the b becomes b squared, right? The b becomes b squared, which we can factor out. So this is b squared divided by 2. Okay, and then we have a 1 minus x squared divided by a squared dx. Okay, is that so? Great. So that is what we have at the moment. Okay, and if we were to integrate that, then we'll have b squared divided by 2. What we have? We have x minus x cubed over 3a squared. Evaluating this from 0 to a, and this finally gives us what? This gives us b squared divided by 2. Okay, what do we have? We have a minus a cubed over 3a squared. That's about it, right? Then we evaluate that, then we'll have b squared divided by 2, a minus, there and there it cancels, we just remain with a, so this becomes just a over 3, right? Which is equal to b squared divided by 2. This becomes a 2 over 3a, right? Okay, and the 2 cancels out. Then we'll have a b squared a divided by 3, which is equal to just ab squared divided by 3. Okay, so we found this part of the top part, so we can write this. We can say y bar is therefore equal to this integral from 0 to a of half, or we can just write it the way it is, integral of y cubed dA divided by integral from 0 to a dA. This is going to be equal to ab squared divided by 3 over dA, which we said is equal to this is equal to ab pi divided by 4. Okay, so if this and this cancels out, we just remain with a b on top. Then with a b, a 4 goes on top, and then we are going to have 4, and we have divided by, because b and b there cancels, just remain with a b divided by 3. Great. So I think we are done. We are done with the problems. Let's write the summary. We have x bar, which is equal to 4a divided by 3 pi, right? 4a divided by 3 pi, and then we have y bar, which is just equal to 4b divided by, there's also a pi there, right? Sorry, this one there's a pi also, a pi down there. Okay, yes, okay, so 4b divided by 3 pi. Okay, 3 pi. Great. I think this is about it. This is really about it. We found our x bar and y bar, our x bar and y bar for this elliptical area, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, and continue subscribing. Bye bye, and see you in my next screencast.